Testing, testing. Right, Math 0092, we're beginning with Chapter 11, Section 4. And we have been working with the addition principle and the multiplication principle, and now we're going to be using these principles together to solve equations. And our first example is 3x plus 4 equals 13. And our goal, of course, is to solve for x equals. We want to isolate the variable. The variable is on the left side of the equation. There's another term, and it's wrapped up in multiplication. So we use the addition principle first to move terms to the other side of the equation. Well, I want to move 4 to the other side of the equation, so I'll add its opposite to both sides. Reason, 4 plus its opposite goes to 0, and 0 plus 3x would be 3x. And 13 plus a negative 4 is 9. Now I'm down to my x term on one side of the equation. Good, I've isolated the x term, but I'm solving for x, not 3x. So now I'll use the multiplication principle to unwrap 3 times x. I'll multiply by the reciprocal of the coefficient on the x term, which is 1/3. 1/3 times 3 goes to 1. 1 times x would be x. But if I multiply by 1/3 on this side of the equation, I'll have to multiply by 1/3 on this side of the equation. So I have x equals, that's my goal, and 1/3 of 9 is 3. X equals 3 is your solution. And you can check. Substitute back into the original equation. Next, we are to solve negative 5x minus 6 equals 16. My goal is to solve for x equals, being able to solve for x. I'll need to isolate the x term first. So I'm going to use the addition principle first. And I need to add the opposite, but I'm not sure what the opposite is yet. Change subtraction to addition and add the opposite. And now I know that I want to add the opposite of negative 6. The sign was tied up in the operation of multiplication. So I'll add a positive 6 to both sides. I'm doing that because the opposites added go to 0, and negative 5x plus 0 would be negative 5x. And 16 plus 6 is 22. Now I'm still not at x equals. I've isolated the x term, but now I need to use the multiplication principle. To multiply by the reciprocal, negative 1/5. Remember, the reciprocal of negative 5 is flip it and keep the sign. But if I multiply by the reciprocal for some strategy on this side of the equation, I'll have to multiply by the reciprocal on this side of the equation. Multiplying reciprocals goes to 1. 1 times x, x equals, that's good, getting close to my goal, but I need to tidy up this side of the equation. And I get negative 22/5. And you can check, substitute back into the original equation and solve. Using the multiplication principle and the addition principle together to solve equations. I'm supposed to solve, so my goal is x equals. I see I have x and some other terms on one side of the equation. Use the addition. A comes before m. Addition principle, multiplication principle. We're going to use the addition principle to move terms to the other side of the equation, trying to isolate x. So I'm going to rewrite this so I know the sign of my terms. I'm going to get this 45 over on the other side of the equation, so I'll add a negative 45 to both sides. Adding opposites go to 0, and I end up with the opposite of x equals negative 45 plus 13 will be a negative 32. I'm getting close. I am solving for x equals not a negative x. So I'm going to have to use the multiplication principle, multiply by the reciprocal. Now, the reciprocal of -1 is -1. So I'll multiply both sides by a -1. Negative times a negative is positive x equals, and a -1 times a -32 will be a positive 32. And you can check back into the original equation. (3x plus 4x equals a -14). Our goal is to solve for x equals, isolate the variable, but in this case we're going to collect like terms first. We have a couple of like terms, so we'll collect them. 3x plus 4x is 7x. We're getting close. We've isolated our x term, but we need to unwrap it. It's tied up with multiplication, so we'll multiply by the reciprocal. The reciprocal of 7 is 1 over 7, and we keep the sign. But if I multiply one side of the equation by something for some strategy, I'll have to multiply by the same thing on the other side of the equation. 7 times its reciprocal goes to 1. 1 times x is x equals. I'm getting close. And now I'll expand this side of the equation. I'll get a -14 over 7. 7 goes into a -14, a -2 times. Check by substituting back into the original equation. (6x plus 5 minus 7x equals 10 minus 4x plus 3). We're supposed to solve for x, so our goal is x equals. Well, I always change subtraction to addition, so I know the sign of my terms. So now I know the sign of my terms, and it looks like I can collect some like terms. So let's do that. I'll have a 6x plus a -7x would be the opposite of x plus 5. And I have a 10 and a 3 for a -4x plus 13. I'm trying to get my x terms on one side of the equation. I prefer to use the addition principle to move my x terms, my variable terms, to the left side of the equation. So I'm going to add the opposite of 4x to both sides. That'll go to 0, leaving 13. And tidying up this side of the equation, 4x plus a -x would leave me a 3x plus 5. Still trying to isolate my x term using the addition principle. We'll move terms first, and then finally apply the multiplication principle. So I need to isolate my term yet. I'll use the opposite of 5 to both sides, and I'll get 3x equals 8. Now I have my single isolated x term. I'm solving for x, though, not 3 times x. So I'll need to use my multiplication principle to unwrap x by multiplying by the reciprocal. The reciprocal of 3 is 1/3. But if I multiply by some value on this side of the equation for some strategy, I'll have to multiply by the same value on the other side of the equation. 3 times its reciprocal goes to 1. 1 times x is x equals, getting close, tightening this side of the equation, that's 8/3. And you can check. Substitute back into the original equation and solve. (8x equals 2 times the quantity, 12, subtract 2x. Here we're introducing parentheses and the distributive property. And we always work within parentheses first to see if we can simplify. Change subtraction to addition and add the opposite so I know the sign of my term. Then I'm going to use a distributive property. 8x equals 2 times 24. 2 times 12 would be 24. Pick up your sign and distribute 2 times a negative 2x, be a negative 4x. Looks like I can collect some like terms. I'll do that with the addition principle. I'm going to add the opposite of 4x, would be a positive 4x to both sides. The opposite of 4x plus 4x goes to 0, leaving 24. And 4x plus 8x is 12x. Remember, our goal is x equals. Now I have my x term isolated. It's on one side of the equation all by itself, but I have 12 times x. So now it's time to use the multiplication principle. I'm going to multiply by the reciprocal of the coefficient on the x term. The reciprocal of 12 is 1/12. If I multiply by 1/12 on this side of the equation, I'll have to multiply by 1/12 on this side of the equation. A number times its reciprocal goes to 1. 1 times x is x equals, getting close to my goal, I'll have to tidy up this side of the equation. Remember, this is a whole number, 24 over 1. Multiplication of fractions is a piece of cake. Multiply the numerators, multiply the denominators, and simplify if you can. And 12 goes into 24 twice. Check by substituting back into the original equation. Now the process that we've seen using the addition and the multiplication principles together to solve equations. This is on page 670. Solving an equation. If the equation contains parentheses, of course, multiply using the distributive laws to remove them. Collect any like terms. Get all terms with variables on one side of the equation and all constant terms on the other side of the equation, using the addition principle over and over as necessary to move terms to the other side of the equation. Collect terms, like terms if possible. And finally, your variable term will be isolated, and you use the multiplication principle to isolate the variable, solve for your variable, and then check your solutions. This is the process we use over and over and over. And all I can do is emphasize that you use the addition principle repeatedly until you've isolated the variable term. If there's a coefficient on the variable term, multiply by its reciprocal to isolate the variable and then solve. Next is section 11.5. And here we're looking at a tip or a trick to clear an equation of fractions or decimals. Usually fractions and decimals can easily allow us to make a silly mistake. So if we can get rid of them, we can likely be a little neater and maybe avoid errors. So our first example is 2 subtract 5 times the quantity x plus 5 equals 3 times the quantity x minus 2 minus 1. Now always we take care of subtraction, so we know the sign of our term. So I have 2, change subtraction to addition, a negative 5 times the quantity x plus 5 equals 3 times the quantity x. Change subtraction to addition and add the opposite. Change subtraction to addition and add the opposite. Now I can expand by using the distributive property. 2 plus a negative 5 times x would be a negative 5x, plus a negative 5 times 5 would be a negative 25. 3 times x is 3x, pick up your sign, and 3 times a negative 2 would be a negative 6, plus our negative 1. We can do some collection now of like terms. Here's a constant and a constant, so I have a negative 5x plus a negative 23. I have a 3x and a negative 6 plus a negative 1, it'll be a negative 7. I like to move my variable terms to the left-hand side of the equation, so I'll do that with the addition principle. I'm going to add the opposite of 3x to both sides. Adding opposites goes to 0, leaving a negative 7. A negative 3 plus a negative 5x will be a negative 8x plus a negative 23. I'm still trying to isolate my x term, so I'll use the addition principle again, over and over and over until I've isolated my variable term. To move 23 to the other side of the equation by adding the opposite. Opposites go to 0, I get a negative 8x, and a negative 7 plus a positive 23 is equal to a positive 16. Now I have my x term isolated, but I'm solving for x, not a negative 8 times x. So now I can use my multiplication principle to multiply by the reciprocal of the coefficient on the x term. The reciprocal of negative 8 is flip it and keep the sign. But if I multiply by a negative 1/8 on this side, because of some strategy, I'll have to multiply by the same thing on the other side of the equation. A number times its reciprocal goes to 1. 1 times x is x equals. And tidying up this side of the equation, I have a negative 16 over 8. And simplifying 8 goes into a negative 16, negative 2 times. Continually use the addition principle to assist in isolating your variable term. And then if necessary, use the multiplication principle to unwrap x. So your variable is isolated. Four thirds x plus 1 equals x. We're told that if we have fractions in an equation, if we multiply by the least common multiple of all, the key is here, all denominators, we can get rid of fractions. So let's see, there's only one denominator here, 3. So I'm going to multiply all terms on all sides. So on both sides of the equation, I'm going to multiply by the least common denominator, which is 3 in this case. Now watch what happens. 3 times 4 thirds. Well, 3 goes into 3 once. 1 times 4 is 4x. Pick up your sign. And 3 times 1 is 3. And 3 times x is 3x. So I now have gotten rid of fractions. This is page 674. To clear fractions in an equation, we multiply on both sides of the equation by the least common multiple of all denominators. So we've gotten rid of fractions by multiplying by our least common multiple, which was We only had one denominator. And you multiply all terms on both sides. You can't just pick a term. We have to keep our pendulum balanced, so we're multiplying everything on one side of the equation, and we're multiplying all terms on the other side of the equation. So now it looks like we can collect like terms. I'm going to add a negative 3x to both sides. That'll leave x plus 3 equals 0. I'm still trying to isolate my x term, so I'll use addition principle again to add a negative 3 to both sides. Opposites go to 0, leaving x equals a negative 3. And you can check, substitute back into the original equation, and solve. Five sixths a minus 3 equals 1 plus 7/8 a. In this case, my variable is a. My goal is a equals. So again, I'm using my addition and multiplication principles to isolate the variable term and then solve for a equals. But I have fractions, so let's get rid of them. To get rid of fractions, we multiply by the least common multiple of all denominators. So let's pick up our table. In our table, we pick up all denominators represented, and we'll find our least common multiple. Prime factoring 6 is 2 times 3, and prime factoring 8 is 2 times 2 times 2. We need both factors from the first column. There are none represented yet. From the second column, we have a factor of 2 represented, but I'm going to need another factor of 2, actually another factor of 2. 2 times 2 times 2 is 8 times 3 is 24. And sure enough, 6 goes into 24, and so does 8. So my least common multiple is 24. Now, getting rid of fractions, we're told multiply both sides, all terms, by your least common multiple. Whoop. Copied that down wrong. 5 6a minus 3. And we're going to multiply times 24, our least common multiple. On this side, I have 1 plus 7/8a. I'm going to multiply that by my least common multiple. So I'm multiplying by the least common multiple on both sides of my equation. Now watch what happens. 24 times 5, 6. Well, 6 goes into 24 4 times. 4 times 5a would be 28. Pick up your sign. 4 times 3 is 72. I'm going to distribute. 24 times 1 is 24 plus 24 times 7/8, but 8 goes into 24 3 times. 3 times 7a would be 21a, using my distributive property. Well, I'd like to collect my variables on one side of the equation, so I'm going to add the opposite of 21a to both sides. Adding opposites goes to 0, leaving 24 on this side of the equation. And 20a subtract 21a would be a negative a minus 72. Still trying to isolate my variable term, so I'll use the addition principle again. I'm going to change subtraction to addition and add the opposite, so I know the sign of my term, and I'll add 72 to both sides. Adding opposites goes to 0, leaving a negative a, and 24 plus 72 is 96. Now I'm solving for a equals, not negative a. So I'll use my multiplication principle to multiply by the reciprocal, and the reciprocal of negative 1 is negative 1. I'll multiply both sides by negative 1. Negative 1 times the opposite of a would be the positive a, and negative 1 times 96 would be a negative 96. And you can check. So a tip or a hint. When you have equal fractions in your equation, you can get rid of those fractions to help us solve more neatly and maybe make less silly mistakes by multiplying all terms on both sides of the equation by the least common multiple of all your denominators. (16.3 minus 7.2y equals a negative 8.18. Well, the same thing holds true when we have decimals. When we have equations with decimal values, it might be nice to get rid of those decimals first and then solve. It helps us eliminate making some silly mistakes. And to do this, to clear decimals in an equation, we multiply on both sides of the equation by a power of 10. To determine which power of 10, we count the greatest number of decimal places in any one number, and then we choose the power of 10 that contains that many zeros. For example, if the greatest number of decimal places is 1, we multiply by 10. If the greatest number of decimal places is 2, we multiply by 100. This is on page 676. So in this case, there's one place. Here's 2 places. So I'm going to multiply both sides of my equation by 100. So I've multiplied both sides by the greatest number of decimal places in any particular number in my equation. Now watch what happens. Using the distributive property, 100 times 16.3 is 1060. Pick up your sign and distribute 100 times 7.2 is 720 times y, and 100 times a negative 8.18 up a negative 8.18 times 100 is a negative 818. And now I got rid of decimals. Not a lot to it. We're just sliding the decimal point, the necessary number of placeholders in order to get rid of decimals. But we have to multiply by 100 on all terms on all sides of the equation. So now I see I have a variable, and my variable in this case is y equals. So I want to be able to isolate that term and then solve for y. So I'm going to use the addition principle. Add the opposite is 1630 to both sides of the equation. Adding opposites goes to 0, and I end up with a negative 720y equals a negative and 818 plus 1630 is a negative 2448. I'm getting close. I'm not quite at y equals. I have a negative 720 times. So there's your key. We'll use a multiplication principle and multiply by the reciprocal. The reciprocal of negative 720 is flip it and keep the sign. But I'll need to multiply this side of the equation by a negative 1 over 720. Multiplying both sides by the same value, a number times its reciprocal goes to 1. 1 times y is y equals. Getting close. Now I need to tidy up this side of the equation. Negative times a negative is positive. 2,448 times 1 is 2,448 divided by 720. That's obviously even, so let's take a look with our calculator. 2,448 divided by 720 is 3.4. Your answer is 3.4, and you can check by substituting back into the original equation. And we have 41.68 is equal to 4.7 minus 8.6y. We're supposed to solve for y. But I have decimals, so let's get rid of them. There's two places. Here's one place. Here's one place following the decimal point. We're going to multiply by 100. We have two placeholders, 10th, 100th. So we're going to multiply both sides of this equation, all terms on both sides. Times 100. Least common, we've got two placeholders here, and one following the decimal point, one following the decimal point. So we'll multiply by 1 and 2 placeholders. So 100 times 41.68 is 4168. 100 times 4.7 is 470. Pick up your sign and distribute 100 times 8.6 equals 860 times y. I always change subtraction to addition so I know the sign of the term. I like to have my variables on the left-hand side of the equation, so I'll use my addition principle now to move my y term. I'll add the opposite to both sides. Adding opposites goes to 0, leaving 470 on this side of the equation. And I have 860 times y plus 4,168. Still trying to isolate my y term, so I'll use the addition principle again, and I'm going to add the opposite of 4,168 to both sides. Adding opposites goes to 0, and I end up with 860 times y equals a negative 4,168 plus 470 leaves a negative 3,698. I have my y term isolated finally, but it's 860 times y, so we're going to use the multiplication principle. Multiply by the reciprocal. The reciprocal of 860 is flip it and keep the sign. If I multiply this side by some value, I have to multiply this side by the same value. A number times its reciprocal goes to 1. 1 times y is y equals, getting very close. Tidying up this side of the equation, I'll have a negative 3,698 divided by 860. Negative 3,698 divided by 860 is a negative 4.3. And you can check by substituting back in to the original equation and solving. So in this section, we learned a couple of techniques to get rid of fractions and to get rid of decimals when your equation is presented with decimals or fractions. This assists us to work with a little neater solution and maybe avoiding making mistakes when we work with fractions or losing a placeholder when we're working with decimal points. So it's always a good idea, if an equation contains fractions or decimals, that we clear the fractions or decimals using our demonstrated techniques. All right, please return to D2L Brightspace for all your details regarding homework, assignments, and tests, and their due dates. Thank you very much.